can't hear you. There we go. Okay.
How about now?
Yep.
Okay. Sorry about that. Good afternoon, everybody. Welcome to Check. My name is Cole Kelly. I'm from Emporia State University. I'm an enterprise systems architect. Today's session is Tour de Azure 2020 by John Keffler. If you have any questions, make sure to use the submit a question button from the page for this session on the Check website.
All right. Well, thank you very much, Cole. Thanks everybody for watching today. I'm excited to be here at Virtual Check to talk about Azure with you all. I hope you've had a good conference so far. I'm going to share my screen here so that I can give you some demos. We'll do some demos and also take a look at my PowerPoint. Okay. All right. So first, just a little bit about me. My name is John Keffler. I am a CIS instructor, computer information systems instructor at Pittsburgh State. I'm also the co-founder of a software development company based in Pittsburgh called Dev Squared. And I'm also a Pluralsight author. So I author coursework and content for a company called Pluralsight that enterprises use to train people. So I wear a lot of hats. I wear some educational hats. I wear some private industry hats. And so I get to see a lot of different things with Azure, and I'm excited to share those with you today. My contact info is on the slide. Feel free to send me an email, hit me up on Twitter, whatever is best for you. If you have any questions or want to get a hold of me, don't forget to use that form in the YouTube comments that they sent to submit any questions as well. So let's talk about the elephant in the room. And of course, that is COVID-19, right? So, we've been dealing with this for a few months now, and that has really fundamentally impacted the way that we do business, the way that we work. And I wanted to be sure to mention this a little bit because the cloud and Azure in particular has been very much impacted by what's gone on with COVID-19. And many of you may have been exposed to this as well. And one of the biggest things that happened with COVID-19 and Azure was a huge increase in demand for Microsoft's cloud, and that caused them some issues. There were some capacity issues and things like that. And so this is a snippet from what Microsoft put out on March 28th about this. So they had a lot more demand for things like Teams, virtual desktops, Power BI. At first, they said they had a 775% increase in cloud service demand. So it didn't end up being that high that cloud service demand increased, but they still had a huge increase in cloud service demand to the point where they weren't able to provision virtual machines for some people who wanted them. What they did have a huge increase in demand in 775% in was Teams. And you're probably all experiencing this at your institution. At my company, we used Slack before this, and at Pitt State, we hadn't really completed a full migration to Teams, but this really forced our hands, and now everybody uses Teams all the time. So this was a really good thing for Microsoft from that perspective. And in addition to that big spike in Teams usage, of course, Power BI, virtual machines, virtual desktops. So Azure was really stretched to their limit. And if you didn't already have a piece of that cloud pie, you had some trouble getting it for a while, which I think is a really interesting point. And I think kind of leads into a question of, is it a good idea to kind of get a foot in there now, even if you don't necessarily think you have to yet, right? What if there is another supply and demand issue in the future? So I just thought that was interesting to touch on because it's relevant to what we're facing right now with COVID-19. Now, why choose Azure as your cloud platform? I'm going to talk about a few reasons why I think Azure makes a good cloud platform, and some of these things apply to any cloud, but some of them are Azure specific. I'll go through these different points here. I'll go through several different scenarios you may have, whether you're kind of looking to be cloud native, whether you're hybrid, whether you're all on premise, what Azure can do for you. And I'll also talk about some tips and tricks, best practices, things like that. So there'll be some basics, some advanced stuff, hopefully some new stuff you haven't seen. We'll touch on some Azure labs as well. I'll do some demos. So hopefully there's something in here for everybody. And I'm kind of pulling from my experience at my software company where we use Azure primarily as our stack to host software. And I'm also pulling from my experience as an instructor. I teach students how to use the Azure cloud in the classroom because there's a huge amount of demand for it from a lot of companies. So why choose Azure? Well, reason number one is rapid elasticity. And really what this means is the ability to quickly spin up more resources or the ability to quickly contract your resources as needed. And this is just a huge pro for the cloud in general. If you think about our resource usage, there are a lot of servers that we have on premise that just sit and do nothing for a large amount of time. And one of the great things about the cloud is we can quickly build up and tear down resources to accommodate to demand better, to respond to demand better. The other thing with rapid elasticity is we can spin up resources in a geographically redundant way, right? So not only on our campus or maybe a sister campus nearby, but also in China, all the way across the globe if that's necessary. We can have that global redundancy, and that is just not really possible with an on-premise setup. So a couple of things with rapid elasticity. I was talking to someone at a conference, and this person ran a company that sold tickets. They were a small-time ticket sales company, and they had a big customer come to them and say, "Hey, we want you to sell tickets for our event." It was a big country music singer. And this guy knew that his infrastructure was nowhere near where it needed to be able to meet that demand. It'd be like 5 minutes in ticket sales and then it'd be over. So he bought some capacity in Azure. He scaled out to about 900 virtual machines to load balance what was coming in. His tickets sold out in a couple minutes, and then he scaled right back down to the couple of servers that he actually needed on an ongoing basis. He paid, I think, just under $2,000 for that couple of minutes, but he would have no reason to use those servers afterwards. So that's an example of that rapid elasticity that really isn't an option anywhere else but the cloud. And I have a couple other examples that relate to this that I'll cover later on as we go. The other thing about Azure is compliance. And the Azure cloud and Microsoft have more compliances than any of our on-premise setups could ever possibly hope to get, in my opinion. Here's just a list of the different Azure compliances that they have. And so if you're going to be doing something that requires SOC, SOC 2, or something that requires HIPAA compliance or ISO compliance or things like that, Azure's got you covered. Okay, the Department of Defense uses Azure because they have the right compliances, and they're going to have a compliance that maybe you don't. So that's something worth thinking about too. The other thing is you're already using Azure AD most likely. If your school uses Office 365, which I think pretty much every school in the state does, you've got Azure AD up and running. And of course, Azure AD is kind of the cloud version of Microsoft's Active Directory. And it allows you to have sign-ins to your work or school accounts through the cloud. And there's a lot of good applications of this. It's easy to integrate this as single sign-on with other cloud software. It's nice to use this as a user store in the cloud if you're building software that's going to be hosted just about anywhere. So think about that too. You're already using Azure AD. Are there ways that you can take advantage of having that auth store in the cloud? There are some things that can save you money. And I want to be clear about this. Some things are more expensive. It really depends on the situation. I think one thing that tends to happen when we look at cloud providers, whether it's Azure or AWS, is we look at the price of a virtual machine and we get this sticker shock and think, wow, it's way cheaper for me to spin that up in our private cloud. That might be true, that might not be true. And so I'm going to go over some ways that you can spend smartly and perhaps save money, but keep in mind, some things can save you money. And part of it's about economies of scale, which I'll talk about here in a little bit. And then cost distribution is another factor. I don't know if you've ever had trouble getting certain departments on campus to pay for their fair share of the IT pie. Everybody's using all these resources, and so sometimes it gets a little tough to distribute those costs across campus. Well, with Azure, you can easily break up subscriptions or break up your Azure offerings by subscriptions that different areas pay for. So if you've got a piece of software that requires a server that some department wants to pay for or wants to use, you can set up an Azure subscription for them, host the virtual machine on that subscription, and then they have to pay for that. Okay, so that can make it a lot easier to split out those costs. There's also Azure hybrid benefits. So if you have Windows volume licensing agreements with Microsoft, you can apply that to your Azure resources in the cloud, and that'll save you with some licensing costs. And then there's educational resources as well. So Azure has a slew of educational offerings that make it easy to teach how to use Azure products, but they also have things like virtual labs and stuff that is very relevant right now that I'm going to cover later. And finally, you might already have some Azure credit. So Microsoft tends to kind of squirrel away a little bit of Azure credit here and there with different deals that they offer people. So one example is if you have a Visual Studio subscription, or if developers at your university have any Visual Studio subscriptions, they probably have maybe $50 to $100 worth of Azure credit a month per developer. You can use that credit if you're not already to experiment and to utilize resources in Azure. Sometimes subscriptions that were kind of formerly MSDN type subscriptions will also have some Azure credit as well. So it's worth looking around and trying to determine, do we already have some Azure credit we're not taking advantage of? And there's also a trick to getting a bunch of Azure credit as well, which I'll show you here in a little bit. So those are some reasons to choose Azure. Now, as we go through some more specific scenarios, some best practices, stuff like that, it's really important that you establish a baseline, okay? And that baseline is your cost per resource per hour, okay? Because that's how things are going to be priced in the cloud, whether it's Azure or AWS. And when you think about your costs per resource per hour, this is going to be all the things that you put into hosting things on premise, right? So you've got your costs to actually purchase the servers and license the operating systems, your cost for staff that takes care of them, the cost to run the facilities they live in, any of those, the custodial costs if there's cleaning of them, any of those maintenance costs that you pay to keep servers running, that needs to be kind of averaged up and divided by resource so you can come up with a cost per hour per resource. And in a lot of the consulting I do and talking to people that I do, this is one of the biggest mistakes that I see people who have an on-premise infrastructure make. They don't actually know how much it costs to run anything per hour. So you need to know that so you can actually make comparisons between what it costs to run things on premise and what it costs to run things in the cloud. Because what I found is it's usually a bit more expensive to run things on premise than you might think. Okay, you might think, well, yeah, I can add a virtual machine to our private cloud. It's free, right? Well, it's free, but you've already paid for the infrastructure there, which is depreciating over time. You're also paying for the facilities and the personnel that have to maintain the fact that there's a physical machine somewhere. So it's not free, it still costs over time, and you need to factor that in, right? Now, economies of scale does come into play here. If you have a large on-premise infrastructure that's already well established, then it's probably going to cost less to spin up resources on-premise than individual resources in the cloud. Okay, so you just have to have that cost established though, so you can make good comparisons and plan. Now, a couple of just overall Azure best practices I want to go through before we kind of get into a few specifics and demos here. One thing that's very important is the subscription in Azure determines who pays, okay? And so some of this is kind of basic, but it's pretty fundamental and pretty important. So I'm gonna flip over to my Azure account here. So I've got an Azure account I'll be using here to do some demos. And if I go to the subscriptions area here, I have several different subscriptions here. And each of these subscriptions can have a different person paying for it. So that's when I said earlier, maybe you want to set up subscriptions for other departments so they can pay for that piece of the pie that they want to use, right? So plan your subscriptions out so that different areas can pay for them as is appropriate. Okay, so subscriptions determine who pays. All of these are under the Pittsburgh State University umbrella, but they can be split up by different people paying. Use the pricing calculator. Okay, this is a fantastic feature of Azure that a lot of people don't seem to use, and hopefully if you use Azure, you're using it. But if we go to Google and we search for Azure pricing calculator, that'll come right up. And this is a really easy way to get a baseline for how much something's going to cost, because that is important. So let me real quick throw together what I might do for hosting a web application for a customer. Right? Maybe I want a virtual machine. and I'll come down here after selecting that, and we're going to run it on Linux, and we're going to run it at a standard tier, and we're going to run it, you know, at one of these lower end tiers, something like this, maybe 1 CPU, 4-ish gigs of RAM, something like that. And that's probably even too much there. As you can see, there's quite a few options. So this tool helps you to see, you know, what they cost. So maybe that's better. Okay, so I have a virtual machine. I also need a database. So we got Azure SQL database here. I'll just click that. It's going to add it down here. I can come down and I can say, you know, where is that going to live? What kind of database am I going to do? I'll do a managed instance here. Sorry, a single database rather. You know, general purpose, what compute, stuff like that. Not that many cores. Go with the DTU model. There we go. That's what I was looking for. Maybe we'll go with a standard tier. There we go. 15 bucks a month. Okay. And then finally, you know, usually I need to have like some blob storage or something, which is only a couple dollars. So, you know, from this, I've got a cost estimate, what all this is going to cost for each thing. And so the total here for hosting a web application per month for this customer might be $46 a month. And you can easily export that or share this with anybody who needs to see it. Like here, I'll do the export to Excel. This is what I'll usually get out of the pricing calculator and send to people. And it gives you a nice breakdown of everything, how much it's going to cost, stuff like that. And I'll use this as a template later when I go and build stuff out. So use the pricing calculator to see how much is stuff going to cost beforehand. And maybe by using the pricing calculator, you'll also see some options that you didn't know were available. Okay. So let's go back to the slides. Also, use your resource groups wisely. So what are resource groups? They are groupings of items that can be transferred between subscriptions. So if I go back to my Azure account, go to resource groups. Resource groups should have a group of similar things that you want to keep together. Okay, so I've created a check resource group where I'll be putting anything I make today. But if I was going to say, make a web application to deploy for enrollment or something like that, I would make a resource group for enrollment. And then the other thing about resource groups is you pick a region for them. And then the stuff in that resource group is typically going to be in that region. And the best practice here is to pick a region close to you for network latency purposes. Now there is elasticity and redundancy and geo and stuff you want to think about. And so you may create other resources across the globe, but generally for your basic stuff, you want to keep it close to you as possible. Okay. The other thing about resource groups is if you ever want to transfer resources from one Azure subscription to another, that's how you do it with resource groups. So you would go into a resource group and then you could transfer it from one subscription to another. So that's another reason to keep all similar things, all things that are part of the same kind of platform or application together in one resource group. So it's easy to transfer them later. Use anything you can that's free. Azure is a gold mine of free resources if you go looking for them. So there is a whole page here that tells you all the things that are free under Azure. So a couple of things that come to mind here. A whole bunch of blob storage or file storage for free. Certain SQL, managed SQL database instances for free. Let's see what else we got here. Azure Maps. So if you need some geocoding, you can get that for free. Azure App Service. So hosting web applications, there's a managed service for that that has a free tier, and so on and so forth, right? So there are many, many free tiers of applications here. These are going to be lower end, but maybe you have a basic need that one of these meets, or maybe you want to test something for free. Look at all these free resources and try and leverage them, right? It's free stuff that's going to waste if you're not using it. Okay. Think about where network latency hurts you. So this is something I hear a lot about going to the cloud. Well, it's so slow. It's only really slow if you're not thinking about where you're putting things, right? So if I've got a web application that I host on premise and a database in the cloud or vice versa, there's going to be some latency there, right? There's going to be latency communicating between the web application and the database. It's better to keep those kinds of things together. Keep them both in Azure. Keep them both on premise. And keep in mind too, with any kind of web application or website, you're already eating some latency when people navigate to that from the web. So you're going to have that no matter what. But keep web apps and database backends close together, right? Keep things like domain controllers on premise for the most part. If you're going to put a domain controller in Azure, make it a second site and only make it service things in Azure, right? So cluster things and keep things close together to avoid a lot of latency. Because yeah, there's always going to be better speeds when you're talking to a bare metal box that's right down the hall, right? So for things like file storage and stuff like that, that you want to be quick and accessible, it makes sense to keep that on premise. For things where you're already eating a latency cost already, like a web application or web server that people can access from anywhere, it doesn't make as much sense necessarily. Security is up to you. I think we all should know this by now, but there used to be this misconception that cloud security just came for free. Of course, you are the one who's responsible for securing things that you set up in the cloud. And the nice thing about Azure and AWS is the same way, is they're pretty good about warning you if you're going to make a security mistake, if you're going to leave that port open that shouldn't be open. They have good, strong password policies out of the box. They encourage you to use things like two-factor authentication and whatnot. But at the end of the day, securing your virtual network or virtual servers or whatever you set up in Azure, that is up to you. And so good system administration practices still apply across the board. Don't forget about backups. So there are a lot of Azure resources that kind of have automated backups that work really well for you. Their managed SQL server is a good example of this. It auto backs up for a time period. It's very easy to restore. But there may be other things like virtual machines, stuff like that, where you want to go and make your own backups. And for the most part, Azure has backup services you can deploy for anything. It's a little bit of an extra cost, but if you need that, don't forget about making backups. And also try and configure your stuff in the cloud to be built up and torn down quickly. So whether that's using kind of deployment scripts or automation to quickly add and remove resources, whether that's if you have like code that you're publishing to a web server, if that's being able to reproduce that code publishing process over and over and over again, try to set things up to where they're kind of expendable almost, because that's going to make it easier for you to quickly leverage that elasticity of the cloud. And then finally, leverage templates and automation. And I have a lot to show, so I think I'm going to skip this. But every time you go through and set up a resource in Azure, it will give you a template to automate that. Like it'll let you copy and paste the template script to be able to automate setting up that resource again. So use the Azure command line interface, use the template scripts that you get out from doing it manually once to automate these processes and make them super easy for you in the future. And that goes well with quick build up and tear down as well. Now, let's go through a few scenarios that you may find yourself in, right? So maybe you're a well-established on-premise shop, which I think probably applies to the majority of universities in Kansas, right? So in this case, you're not really looking to migrate to the cloud. You're thinking about it. Is there any advantages? But there's no reason to not use that great infrastructure you built on campus for things. So what I would say for this is at least create a budget for cloud type one-offs, okay? Whether that is some kind of emergency like this COVID pandemic where suddenly we need to be a little bit more agile. Remember, you've got that rapid elasticity in the cloud. Maybe it's difficult for people to get to campus due to what's going on. So I would have an emergency budget for cloud one-offs to be able to spend that money on elastic resources if you need to. You're not planning to, but you have that available. Another thing you can use is leverage our dev test environments or virtual labs. And I'm going to talk about virtual labs here. I'm going to show a demo of them toward the end of the presentation. So we'll get to more specifics there in a bit. But the point is, even if you have a well-established on-premise architecture, a lot of universities are looking to kind of move away from on-campus labs or reduce costs with on-campus labs. And especially now that we're dealing with COVID-19, we don't know when we'll have students back on campus. Those machines are just sitting there pretty much collecting dust and doing nothing for us. And even in the best of times, when we have students on campus, those machines sit and do nothing an awful lot of the time. So what if there was a way with the cloud we could get around that? Well, that's what I'm going to talk about later when we get to virtual labs. And then finally, blob storage. So if there's one cloud resource that you choose to leverage in Azure, even if you have a well-established on-premise environment, I would highly suggest that you look at Azure's blob storage or storage account offerings. So it's incredibly cheap to store a huge amount of data in Azure, and they have tools to make it easy to transfer that data back and forth. So whether that's archives or backups, or even like content, like images, videos, stuff like that, stuff you don't necessarily want to clog up your on-premise network with, Azure has a lot of good options for that in their blob storage setup that's very inexpensive. And I'll show you in the pricing calculator here in a minute. Azure also makes it very easy for you to set up CDNs or content delivery networks, which if you don't know what a CDN is, it's basically leveraging cell towers and cellular providers to more quickly offer access to media to people who are trying to access it. So it's really nice to have that option if you for maybe your website or your CMS or something like that. And just to show you how low cost this is, if we go to the pricing calculator here and add a storage account, scroll on down here. Maybe I want to keep it in the central US region that's closest to us. I think that's in North Dakota. We're going to go with some blob storage. So this would be like storage for images. Performance tier, we can say standard. Access hot, so quickly access the stuff. Maybe we go with globally redundant storage, just so that we know it's being spread out geographically. 1,000 gigabytes for $36 a month. Okay, many thousands of operations. Okay, it's very cheap. And this is the primo tier storage, right? If I go to something more like premium, or sorry, not premium. If I go to archive access tier and we go with locally redundant storage, so not geo-redundant storage, now that's what we're looking at for 1,000 gigabytes, right? So how about 5,000 gigabytes a month, 10 bucks, right? So huge amount of data you can store for a very minimal cost. So if there's a use case here for doing this, and then you don't have to worry about having a bunch of extra storage on premise, I would suggest it's worth looking into. Now, if you have or are trying to get to a true hybrid environment, let's talk about that. So I will say, first of all, hybrid environments are kind of tricky. And usually there's kind of an end goal behind having a cloud and on-premise hybrid environment. So one goal is an eventual full cloud transition. Okay, that's one goal some people have. Another goal is just to have redundancy. So, I have this critical server on premise. I want to have this critical server in the cloud as well, and that's fine. And then elasticity can be the last goal. So let's say that we are working with students across the world. Maybe we have a big student base in China. And in order for them to be able to access resources from us in a quicker way, maybe we want to set up a set of Azure virtual machines that are hosted in China, and then use a load balancer so that when our students access those, they have less latency. So that might be an elasticity use case here, and geo-redundancy use case rather, okay? But hybrid environments are tricky. You do need to have a VPN gateway set up. So that's kind of thing number one that you have to do. If you've got an on-premise domain controller, you need to have a VPN gateway to your cloud virtual network so that you can join any virtual machines in the cloud to your domain and access any on-premise databases and stuff like that. But once again, I will say, try and avoid having that latency. Okay, if you're going to have virtual machines in the cloud that you want to connect to a domain controller, make a second site in the cloud, put a different domain controller up there, and make sure the cloud VMs are talking to the cloud domain controller. Make sure your on-premise VMs are talking to your on-premise domain controller, okay? You might do the same thing with a database. You might replicate a database to the cloud and have the cloud web servers talk to that database and on-premise servers talk to the database version on-premise, okay? But the nice thing about that hybrid setup, if you do kind of get things going that way, is it's a nice safety net, right? So let's say there's a fire on campus or a tornado tears through. If you've got those critical resources running in the cloud as well, that may mean that you're back up and running very quickly. So this environment, it's complicated, but it can have big benefits. I would just say, once again, think about your end goal. And I kind of went over this already. You want to make sure to keep things together that make sense, keep databases and web servers together, and so on and so forth. And if you want to become a cloud native type person, okay, if you want to become a cloud native, so to speak, organization, the first thing you have to do, of course, is set up your cloud network architecture. Okay, so just like planning a network on premise, plan your network in the cloud, set up your subnets, make sure that people can VPN to that network, things like that. Also, I would maybe stress or emphasize, try and make less virtual machines, try and use more managed services, okay? The cloud is really good about these managed services that are a little more hands-off and easier to use for people. I mean, virtual machines are great and all, they're kind of an infinite well of things we can do with a virtual machine, but they're also more expensive. So maybe consider using managed services like Azure Managed SQL or Azure Functions or Azure Web App Service. And I'll talk about these in a minute. In fact, I'll talk about them right now. So like one example, okay, would be Azure Functions, okay? So let's think about a really annoying scenario that a lot of us have probably had to deal with. With COVID-19, we've got, possibly COVID-19 health-related alerts that we've had to post here, there, and everywhere, right? In our mobile apps, on our CMS, 10 other random places. Where do we host this message? How do we easily update it? It's kind of a small problem, but a very annoying problem to have. So let's see how the cloud can solve that for us in just a couple minutes. So if I come in here and I create a resource, and I want to make an Azure or a function, okay, a function app, I'm going to create that. And this is kind of that cloud native thought process now. Let's make kind of a microservice. Let's make a small free thing to handle this. I'll put it in my check resource group. I'm going to call it check notify or something like that. .azurewebsites.net. It'll be published with code. It'll run with .net. And it'll be in central US because that's where our resource group is. I'm going to go ahead and just create it, not do any of the advanced options here. So I'll hit create and it'll spin it up. And this is my absolute favorite thing. Let me fix this real quick. This is my absolute favorite thing about the cloud. That's going to be up and ready for us in just a couple of minutes. Okay, so let's take a look here. Almost done. Okay, it just deployed the web application. It's deploying some storage for it, and then it's going to be good to go. It's done. So that's awesome. Okay, now, and this is under the free tier, right? So it's going to be free as long as we don't overuse this. I guess it's not quite done yet, but it should be here in a minute. And all we're going to do here is just make an API endpoint that's going to serve up a COVID-19 related message that we can easily update, that we can get rid of as soon as we don't need it, all that good kind of stuff. And while that's finishing, let me just flip back to my PowerPoint. This is an example of that kind of cloud native network architecture you might need to set up. It's very simplified, but you would have considerations like setting up subnets and where do we want our public web service to live, or our developer resources, our all employee resources, our production resources, stuff like that. You've got to plan all that out ahead. Sweet, so this is done. Let's go to the resource. And I'm going to click the functions button here. And just throw in just a teeny tiny little piece of code that's going to give us some notification text. And there are a lot of great things that you can do with Azure Functions. If you want to create a one-off microservice, a one-off resource, something that's triggered based on a database being updated, very easy to do. So I'll just add one here. And we're going to go with a HTTP trigger. And we'll just leave the default name, and that's fine. We'll create it. And then I'll be able to add my code to it. Okay. So you can do this right from your browser, which is nice. I'll just go to code and test here. And I could also do it from a Visual Studio on my machine. There's some default code here. All I'm going to do is replace this with return new OK object result. This is a COVID-19 announcement, right? So you can imagine we'd put some information, some links of where to go. Maybe this would be some HTML, right? That's it. I'll just save it. And we'll go ahead and hit test to make sure it actually works. And one thing I want to do here is I don't want this to be a post. I just want it to be a get. So whenever somebody calls a get request on this, I want to be able to pull this data. So let's see here. I was just in here yesterday doing this. And we could probably just run it this way as well. So let's just hit get function URL. And it's going to give me a URL for this function that we can then call. And then if I pop over in my browser and paste this in, you can see there's kind of an API key on the end of here. So we have to know that. Hit enter. And there you go. So we could pull this information in now from anywhere we needed to for the duration of this pandemic. We could change the message in about 2 seconds, or we could change this function to read from a database, even if we had one up here in the cloud, and just use that, right? And then delete it when we're done. So that's kind of more of a cloud native mindset there, but this is free. It's a great thing about Azure functions when you use them in a limited capacity. So just one quick example there. All right, now let's talk about a few education specific resources. This is kind of my last thing today. So there is a resource here, or a page, azure.microsoft.com/education. And if we go to that, that goes over kind of the 3 main things that they have on offer. You've got Azure for Students, where students can get some Azure credit if they sign up. You've got Azure for Educators, where educators can get that credit as well. So students and teachers can get free Azure credit to use in the classroom. And then you've got a product or a platform called Azure Dev Tools for Teaching, which you can purchase as an institution. And this replaced like DreamSpark or Imagine Premium. Now it's Azure Dev Tools for Teaching, so you may already have it. And through this, students can get free software and a bunch of free resources. So it's really great. One tip here that's kind of fun, if you want to, as someone with an .edu email address, you can sign up for Azure for Students and get the free Azure credit. So if you want to play with Azure for Students, just sign up here from this page and you'll get that free Azure credit. You'll get it once, and then you can use that to test things out. So Azure for Students, Azure for Educators, great for students and educators in the classroom. That's what I use with my students. The tip I was going to give you was register for that. You know, even not as a student, you can get access to it. Azure Dev Tools for Teaching, I'll show that real quickly here. Like I said, if you had Imagine Premium or DreamSpark before, this replaces that. So from my Azure account here, I'm just going to go back to the main page, and I've got an education button here. If I click on that, this is going to go into the Azure Dev Tools for Teaching section here. Here's how much of my student credit is left. I also redeem the student offer to use that in class. You can go to software though here, and here's all this free software that students can download. So that's super awesome. Tons and tons and tons of it. So very cool. Additionally, there's all kinds of tutorials and things like that that instructors can use with students to learn how to build things in Azure, or that you could use to learn how to build things in Azure. Okay, so that's Azure Dev Tools for Students. Students can renew their credit once a year. So once a year, they can reapply for that $100 in credit. And I'm assuming so could we as people with .edu email addresses. Now, last thing that I want to show is an overview of setting up a lab in Azure. So we'll do this real quick here. We're kind of getting short on time. So Azure has this feature called Azure Lab Services, okay? And so in order to use Azure Lab Services, you just go create a resource, and we'll search for Azure Lab Services, There we go. And this is a replacement for your on-premise labs. And I really like this because I think it solves a lot of the problems with on-premise labs and the management of them. I know as an instructor, I'm constantly talking to my tech, hey, can we get this software for next semester? Can we get that software for next semester? I just soon set it up myself. This gives us an option for that. So when you create the lab account, you just give it a name. So demo lab, pick a resource group, pick a region, you're done. And just creating this lab account doesn't really do anything yet. It creates kind of a space to manage your lab machines. Now, I've already done that. So I'm going to go into this lab that I've already set up. And from here, this is kind of the management backend, okay? But if you want to actually start working with lab machines, virtual lab machines, you go here and click Create a Lab. Because the Azure Lab Service backend that you make is kind of a bucket for multiple labs. And we'll sign in with my account here. And so the Azure Lab Services portal itself is just a little bit different looking, and you can see I've got the check lab set up. And here I've got one lab called Intro to Programming. So this would theoretically be for one class section of Intro to Programming. I could also come up here and add a new lab if I have other courses that I need to manage. You know, maybe I've got Intro to HTML or web or something. You pick what version, what operating system you want it to run. You pick the size of the virtual machine, so you can go super cheap, 2 cores, 3.5 gig of RAM, all the way up to something very crazy that you would use for like AutoCAD. Okay, and once you create that, it'll be available. Now I'll go into this Intro to Programming lab as the administrator. Here's what I can do. You have this template virtual machine, and this dictates what software is published in the rest of the lab. So if I was to start up this template and remote into it, then I could install whatever software I wanted and then hit publish. And once I do that, it's going to deploy this template out to all the virtual machines in the lab. So to see the virtual machines, you go look at the virtual machine pool. And right now this lab only has one virtual machine, but I could say, you know, 20 or 10 or 5, however many were necessary. Okay. And you can start or stop the virtual machines. And each user has a quota for how much they can use that virtual machine out of class. And the longer the virtual machine is running, the more you pay. So you want to set a quota that's reasonable for what's actually needed. You can also set a schedule. So if you set like regular class schedule on this calendar here, students can log into the machine during those class times as well. So it's class times plus whatever quota you specify. And then there's a few settings you can do as well. To get students into the lab, you just add them through here. You can invite them via email or whatever you might do. And then you can share this registration link with those students. And they can go to that link and sign in with their school account here, which I'll do right here. And once I log in, if I have not been assigned a virtual machine yet, it's going to assign one to me, if there's quota available. Okay. I'm having trouble getting signed in and we're getting short on time, but what would happen is when I signed in, I would get assigned to this virtual machine and then I'd be able to use it against my quota. And so when I log in, I'm going to see something that looks kind of like this, and then I'll have an option to remote into my virtual machine as a student. Okay. And the nice thing about these labs is you can set these up and then give whoever you want to access to manage the template machine and stuff like that. So if you have different departments or different areas, different instructors, and you give them you know, some lab spaces, they can kind of manage that very, very easily themselves. And the nice thing here too is you can see how much it's going to cost. So with one maximum user with 10 total hours a month is what it's set out right now outside of class, that's just $2 a month. So super cheap. What if I amp this up a little bit, right? What if I say, you know, let's up that quota to 10, okay? And you'll see it'll start to spin those resources up here. That might not have been a good idea. It might take too long. But anyway, it would spin those resources up and give me a new cost estimate, and those could be allocated to students. And then when they're not used, they're shut down and you don't pay. So that's the great thing about it, right? There you go, 20 bucks a month. When it's not used, they're shut down, you don't pay. You're not wasting money on lab machines that are running all the time and never getting used. And once a student logs out of these, the policy I have set up is in 15 minutes, they shut down, because why do they need to be on? So it's really, really handy for managing labs. And I really encourage you to look into this if you're interested. Okay, so some closing thoughts here. Azure has downtime just like anything else does. So of course, don't think that it's a silver bullet and you'll never have any downtime if you go to the cloud. And sometimes it's just weird. I had a customer's product deployed to some Azure servers in Texas, and lightning struck those servers. Nothing anybody could have done about it. Could have happened anywhere to anyone. The good news was I was able to move those resources just to a different Azure region in about an hour. So everything was fine. So that redundancy and backup and the elasticity that we had up there was great. Just be aware, Azure has downtime. And I'd also say use AWS also. A lot of companies use both AWS and Azure because they want to have inter-cloud redundancy. And I think that's a good idea to be familiar with both clouds. But I'm more familiar with Azure. I use Azure for the most part, so that's what I wanted to talk about today. Okay, well, that is everything for my presentation. I'd be happy to answer any questions at this point. There you
go. Sorry, I did it again. It looks like we just have one question from Emmeline Hoyt from Butler Community College.
Okay.
And they asked why you chose Azure over AWS, which I think you already touched on, but.
And that's a good question, and I get that a lot. We deploy a lot of Windows resources, and being that Azure is more Windows native because it's Microsoft, that was our reason for choosing that. This is a personal preference for me, but I also think the user interface in Azure is much easier to deal with. I've always found AWS to be a pretty horrific user experience, so that always kind of got to me from the start. That's not a reason not to use AWS. That's a personal preference of mine. But really, yeah, initially it was just deploying Microsoft resources. Azure made the most sense. If I was deploying a ton of Linux resources, we'd probably use AWS for that. So that's kind of my basic answer for that.
All right. Well, it looks like that's all of our questions here. So.
Okay.
Let's see. Thank you, John. Thank you, everybody, for coming to this presentation.
Okay.
And we'll have a good day.
Thanks all. Have a good one.